functions have some useful general continuity properties, okay? So let's talk about these properties in this record. If two functions are continuous on the same interval, f of x is continuous on the interval a, b, and g of x is continuous on the interval a, b, we can say that f of x plus g of x, the summation of these two functions, is continuous on the same interval, and also differences is continuous on the same interval. And the product is continuous. F of x times g of x is continuous on the same interval. For the quotient, like the limit, of course, g of x should be different than 0. So is continuous on the same interval except for values x that make a denominator 0. Denominator 0. This property, by considering the next theorem I will give, enable us to determine intervals of continuity for some important class of function without having to look at their graphs or use the three conditions in the definition. So without considering these three conditions, easily we can decide which function is continuous or which function is not continuous. So let's give them that theorem. First part, a constant function. We have already discussed the limit of the constant function. So the constant function f of x equals key, where key is constant. That's right, constant. This function is continuous for all x. Okay, let's give example. For example, f of x equals 5 is continuous. Okay, for all x. It's not necessary to write the for all x. It is enough to write the continuous. What is the graph of this function? Most probably you know that. This is the graph of that function. F of x equals 5. Graph is like this one. Okay. So easily you can observe this is continuous. Second one, for n a positive integer, f of x equals x to power n is continuous for all x. For example, x to power 4 or x square, x cube, you know all of them. X to power 4 is continuous. Maybe you don't know the graph of this function. It is similar to the x square graph, so but a bit different on this part. So this is the f of x equals x to power 4 graph. In the future, we will sketch the graph of the different type of the functions by you taking that from derivatives. So the third one, a polynomial function is continuous, but just combining this two fact, this fact and this fact, and summation at the multiplication limit idea. Maybe here I can say something. Okay, let's add some other thing. Also, this is continuous. C times f of x is continuous on the interval a b if you multiply the some constant term c. So by combining the summation and this two fact and c times f of x continuity, we can say that all polynomials are continuous. So a polynomial function is continuous for all x. For example, f of x equals 3x to, let's say x to power 4 plus 4x cubed minus 2x plus 1, etc. Okay, so this is continuous function. Next one, a rational function is continuous. It is very similar for the limit idea. Okay, all x except those values that make a denominator 0. So example, f of x equals x squared plus 4 over x minus 2, for example. So it is continuous for all x except x equals 2. Let's give another example. G of x equals x squared plus 4. Okay, let's write another example. For example, x plus 2 over x squared plus 4. Now it is continuous for all x because since x squared plus 4 always different than 0. Okay. Next one, for n, which is an odd positive integer, we separate two parts, greater than 1. So nth root of the x, not x, nth root of the f of x in general. Okay, let's write nth root of the f of x is continuous. Of course, wherever f of x is continuous. So as an example, we know polynomials are continuous. So let's our function g of x is the odd number cube root over 4x squared plus 2x plus 1. So this function is continuous. Last one, for n, which is an even number, even positive integer. So nth root of the f of x is continuous wherever f of x is continuous and non-negative. Non-negative. Why is it to be non-negative? Because if n is odd even number, for example 2, square root of the minus 2 is not logical, or fourth root of the minus 2 is not defined. Okay, not logical is not a good idea, but not defined. So let's give the example. Fourth root of the let's say x plus 2. So it is continuous. Okay, let's say g of x, maybe because f is used for other function. g of x. So it's continuous on which interval? On the interval not all real numbers. X plus 2 have to be bigger than 0. So this have to be bigger than 0. X plus 2 bigger than 0 implies x bigger than minus 2. It can be 0. So on the interval minus 2 to infinity. If f of x always positive, there is no problem. For example, you don't know the continuity of the exponential function now, but for example, let's say 6th root of the e to power x is continuous for all x, since e to power x is always positive.